Good afternoon, everybody. It's a pleasure to be presenting the first presentation of this afternoon on Deep Tech NL and Future of Compute. So deep tech technologies that require a lot of investment, long innovation cycle, and collaboration are one of the cornerstones of Dutch economy. Today I will focus a little bit in a subsection, but also a very important section of deep tech, future of compute technologies, that they will define the barriers of innovation and push them through. In a digital economy, Internet of Things, that's now being enhanced more than ever by AI, there is an increasing demand for computation. Advanced semiconductor, memories, chips are driving that innovation cycle. But I think that's not enough. We are looking at new paradigms of computing, energy, new materials to push boundaries of innovation and help with the growth of our digital economy. But what do I mean by that? Currently, as also the table shows, the biggest driver of computation is advanced semiconductor. This is a field very well known to Japan and also to Dutch economy and companies. And the forecasts are increasing and getting better. So almost a year ago, McKinsey predicted by 2030 the semiconductor industry will be about $1 trillion. But the recent publications has improved and predicting that by 2030 it will be almost $5 trillion. So the demand for advanced semiconductors is increasing, and part of it also demand for AI chips, memory, is increasing more than ever. By 2035, actually we expect that more than 1/3 of the demand is by AI. But advanced semiconductor alone, based on nanoscale microchips and advanced packaging, is not enough. Other paradigms of computing, which both known to Japan and Netherlands, and we have been working on it for many years, will be coming out of the shadow of advanced semiconductor, become more and more important. Quantum computing, that will use the superposition and entanglement of qubits for complex probabilistic computation like drug delivery or cryptocurrency. Photonic computing with ultra-low energy, ultra-fast computation for interconnects, for example. Or neuromorphic computing, brain-inspired computing that can mimic the biological synapses for edge computing also will gain a momentum. And you can see by 2035, they are also our multi-billion euro industries. Currently, all the development happening in silos. So the semiconductor industry innovation, quantum computation, also we see that the Netherlands are very separated ecosystems that working on their own. However, it's changing a little bit, and I think in the coming years, the pace of change will happen more. But first, look at this. Innovation landscape, we did a report together with TechLeap in end of last year. We looked at the whole value chain of innovation and defined 6 elements for hardware innovation that will be driving the deep tech in the Netherlands. So if we look at and this is quite similar for each of these compute paradigms. Material, equipment, and components, where they enable development of design and development of the chips and ICs, will mainly be also Japan has a strong position in that, will help with developing novel compute paradigms. Hardware design, hardware fabrication, where US and Asia are in leading, will be the next layer of this value chain. And later on, electronics, test assembly and packaging, where again US and Asia and increasingly China is getting momentum there, will enable developing the systems that could serve the end user and applications. in future of compute topics, we're looking at the gray zone elements within the value chain of computing and innovation. Keep that in mind, because later on we'll come back a little bit about ecosystem and call for action, which I will show it later. But going back to the compute paradigms, all these compute paradigms are now acting in silos. What will change, and I think would create a disruption in the domain, is connecting these paradigms in an orchestrating way. So it's not that quantum computing will replace advanced semiconductor or vice versa. It's about orchestrating which compute paradigm will act the best and solve the problems fastest, more efficient, and more accurately. And a transducer layer, a hybrid connecting glue, will be a disruptor in this domain. This is why I'm mentioning this, because this is a very critical and a strategic area for ensuring that computation and also serving the applications the right way at a cost-efficient and speedy way happens. Transducer layers are getting momentum. There has been a lot of academic research in this domain, how quantum computers are connected to normal computers. In photonics, obviously, co-packaged optics is a great example of that. But we would like to see how we can go beyond that. So in the Netherlands, now we are collaborating with other applied research partners like IMEC, SURF, to look into that domain and create a more comprehensive hardware and software layer that would orchestrate the communication between compute paradigms. Now, to do that, obviously, we need to look at who will take that role, which companies and organizations will play a role here. So I would like to zoom out a little bit from the technical part of it and look at more the ecosystem part of it. In the Netherlands, we have a legacy, obviously, coming from Semicon, ASML and ASML's network, NXP, all, let's say, the children of Philips and Philips Semiconductor, has been driving the development, and we have quite a global leaders in this domain. Also mentioned in the introduction film, Netherlands has a very strong academic background in compute domain. Not only semiconductor, but also quantum computing, integrated photonics, more than 20 years of experience in this domain. Government plays a key role, so ecosystems like Photon Delta, QDNL, but also Beethoven projects, supported and even stimulated by government supports that as well. And I think Netherlands is a very fruitful, a very, what's the good word? A very welcoming place for international collaborations. Major companies decide to join because of the existing ecosystem, but also the lifestyle, the language barrier, the talents we have in the Netherlands, to join in Netherlands for collaboration working on these world problems. But one of the things that I would like to dive into is the middle part, the fast-growing cohort of Dutch companies. We are very proud of our NXPs and ASMLs and Philips, but the future also belongs to newcomers. And that's what Dutch ecosystem is really stimulating. A cohort of future of compute companies that can push the boundaries of innovations beyond what we are working today. This one gives a glimpse of the companies we have in the Netherlands that are actively working on different domains of future of compute. I will give some different angles of data to show the diversity of work we do. Province of North Brabant have a long history in development of technologies in this domain, and one of the leaders on a number of startups and scale-ups. Also, if you look at the compute paradigms, advanced semiconductor and photonics are the leading part in here. Companies like Acceler AI, Phonontech, Effect Photonics, Smart Photonics are all one of the leaders companies in this domain. And they are being able to raise a lot of funds as well. I think in total, 1 billion euro of deep tech funds has been raised in 2025 and 1 billion in 2024. So it's really showing also in the European landscape, the startups and the scale-ups in the future of compute domain are playing a key role here. Now, if we go back to the value chain I showed, if you map all these startups and the scale-ups, you see there are areas that Netherlands is clearly active and we're playing a role, like in equipment, companies like near-field instruments, Skill, More Photonics are all upcoming stars in this domain. On the component, on the hardware design, we are getting more and more active, and also in system integration. But there are areas like materials, assembly, test and packaging, control electronics, that we could benefit from international collaborations. And by that, actually, I would like to go to my last slide. Looking at the ecosystem in Japan, the involvement in this advanced semiconductor domain and ambitions of Japan, I think collaboration between Netherlands and Japan could result in a lot of strategic developments. Materials and process code development, software and application innovation, on transducer layers and equipment supply chain. And also, most importantly, on ecosystem investment and collaboration at multiple layers, from governmental to universities. Those are the areas that I think the two countries could benefit from collaboration and support each other. And by that, I would like to thank you, everybody,